Hi friends, welcome to our channel. Let's have a look at problem 3637, Trionic Array I. So here we define a trionic array if there exist indices pq in between 0 and n-1 such that so the first part is strictly increasing, the second part is strictly decreasing, and the third part is strictly increasing. So we want to return true if this nums list is a trionic array, otherwise false. So first thing we want to notice is that, so for an array to be trionic, we need at least 4 elements, right? You can from here you can see. So here the constraint is n is greater than or equal to 3 and less than or equal to 100. So in other words, for this problem, the problem size is not very large. But here, in principle, you can solve it using brute force as in the hint. So what we are going to do in this video is to do a linear scan. So let me make some annotation. So the strategy or the method would be linear scan, but we need to we are going to use 2 while loops and a for loop. So this is due to these 3 parts, right? So we can use a pointer to distinguish the 3 parts. So without further ado, let's first look at the coding and then we do some analysis. So first I'm going to get the length of its nums, right? And then I'll start from a original pointer. So the original pointer I'm going to point in index 0. And then the first while loop is used to check from 0 to p, both included, is strictly increasing. So here what we do is, well, the pointer, this is the index, right, is less than n-1. And nums, the pointer at its current position should be strictly less than pointer plus 1, right? So because we want it to be strictly increasing. If this were the case, so we're going to increment the pointer by 1. So after we exit this while loop, there are 2 breaking conditions. One is the pointer equals n-1, right? So actually for this problem, it's impossible to be n-1 because we also have this one. So this current position corresponding to a number strictly not strictly less than the next. So in other words, the current number at a pointer is greater than or equal to the number at a pointer plus 1, right? So this is the case. So now let's check the conditions. First, if pointer equals 0, in other words, you didn't move forward, or the pointer equals n-2. So you know, because so you want to find this p, but after p you still have at least 2 numbers, right? So in other words, so for example, this is a q n-2, right? You need to, the first one should be less than n-2, right? If you were n-2, so we just return false. So this, right? So this is the for the first part, right? Corresponding to the first bullet item. So now let's set the pointer to be the current position, right? So now let's move forward again. So while pointer is less than n-1 and nums at the pointer is greater than nums pointer plus 1, right? So in this case, so the pointer still going to move right. Then we can analyze the stop condition again. So here we are locating the second index corresponding to q, right? So q should be less than n-1, right? So then first, if the pointer equals the p, in other words, didn't increase, therefore this actually has less than 2 elements. So therefore you can not say it's strictly decreasing. Or another one is the pointer equals n-1. So in this case, we just return false. So up to now, we are located the second index, right? The second index such that nums as a current pointer is less than nums at least less than or equal to, right? Pointer plus 1. So what remains us to check is this part. So from the current index up to the end, we should make sure so the subarray is strictly increasing. This is rather straightforward, right? So the for I in range, so the current pointer, right? So then so we need to count the next one. So we stop at n minus 2, right? So this way you can consider I plus 1, right? So what we want actually is this one, nums at I is less than nums at I plus 1, right? This is legitimate because I is ending at n minus 2. But if it violates this condition, in other words, if this was the case, so we're going to return false, right? So after this for loop, if nothing has returned, it tells us that the last part actually is strictly increasing. So we're going to return true. So this is the full logic, right? So let me first run it and test it. Yeah, it passes all the cases. So here, let me do a quick time complexity analysis. So here we basically do a linear scan of this list. Therefore, the time complexity will be O of n, where n is the length of these nums. So actually, this 3 loops, two while loops, one for loop, is exactly corresponding to this 3 bullet points. So let's actually do a slightly refined analysis. So when you look at each of the for loops, so for here, right? So where you stop at a position or index. So stop at a position. Let's see. Let's use this one as an example. Let's call it so I0, right? Or pointer not, right? So such that so the nums at this pointer not actually it's not less than the next element anymore. So therefore, so this will be the case. This tells us that so we this current position will be a position that is the start of this one, right? Same thing when you look at the second while loop, that's why we write like this. But the first one is strictly increasing, the second one is strictly decreasing, right? So the last one is checking the last part. But actually, this problem's assumption implicitly implies that the length of this for an array to be trionic, it must have a length at least 4, right? Otherwise, you cannot find this PQ because all these equalities are strict equalities. So with that said, I guess that's it for the current problem. So what I feel is that this problem is marked as easy, but indeed, when you involve in a problem which deals with index, you need to pay special attention to the stop condition. So with that said, I'll stop here. Thank you.